you can see blue stars kind of on the outside of these spiral arms. And then we find galaxies that are in the process of merging. There's galactic cannibalism going on. This is how galaxies grow in size, and this is this beautiful merger we're viewing here. And anyway, so you can see that we've learned quite a lot just by looking out into the universe. We know that there are lots of other galaxies. Ours is not the only one. When we look inside our own galaxy, so we're looking at things that are tens of thousands of light years away, we find lots of regions where stars are being born. This here is the Orion Nebula. It's the middle star and the sword of Orion. And this here, not too far away, is the Horsehead Nebula. These are regions where stars are being born. And this, of course, is the famous Eagle Nebula that Reverend Neil referred to. Really, Neil is going to be our first minister of our Church of Scientists. He's got what it takes. Anyway, here are these little cocoons that are illuminated, in fact, by stars, bright stars out of the picture above. They illuminate these dense clouds of molecular hydrogen and also dust, and they actually evaporate. The ultraviolet light evaporates the material, leaving these little cocoons. Actually, they're called eggs, and inside each of these is an embryonic star, and the size of these little cocoons is about the size of our solar system. So obviously, everywhere we look, we find exactly what we find here around us. There is nothing extraordinary in seeing in anything that we have around us. And here's just a close-up of that region that I pointed out to you. And then finally, looking only 32 light years away, this is actually, there's a red dwarf star here, and you can see once the light of the star is blocked out, you could see that this star is enveloped with a disk. This is a disk of dust and debris. It's something across like 4 or 5 times the classical limit of our solar system, that is out to about the orbit of Neptune. Of course, we have the Kuiper Belt, and that goes out far. So it's about the size of our solar system, or a little bit larger if you consider our Kuiper Belt. But now we find disks around other stars. They're common. We're finding planets around other stars. We have something, I think I lose count because we're discovering so many of them. I don't remember how many there are now, but I think when last I read about this, we had something like 200 planets around other stars. We haven't yet found any terrestrial-like planets, small planets, because they're very difficult to see. But I think with time it's inevitable. All we need is for the astronomical instrumentation to get capable enough for us to see those evidence of those very small planets around other stars. But planets themselves are common. So we can see that what we find here around us is not unique. And we are continuing in this. We're continuing the trend that began, of course, long ago, most recently with Copernicus. We are losing our very special place in the cosmos. But what about life? Okay, that's a holdover. I mean, the faithful like to hold on to that. What about life? Well, a cardinal goal in the exploration of the planets today is the search for habitable zones in our solar system. And that means long-lived liquid water environments that have also simple organic materials within them and excess warmth. Okay, this has been such a compelling question to see if life was the only place in our solar system, if the Earth was the only place in our solar system where life arose, that this issue of finding other places where it might possibly have arisen, and of course I'm talking only about microbes or even just self-replicating molecules, that it has become a prime thrust for our planetary program. And this brings me to Saturn. As you heard, I am the leader of the scientists who take all these beautiful pictures of Saturn. And here is one of those beautiful pictures in natural color. And I want to point out to you, first of all, that this is Saturn's rings, looked at exactly edge-on. They are phenomenally thin. And in fact, we know that the processes that go on in Saturn's rings are very similar to the processes that go on in the spiral galaxies and also in those debris disks that we find around other stars. So we actually have the capability of understanding those processes by examining what is contained in Saturn's rings. But I want to call your attention to this little body here. It's called Enceladus. It's no bigger than the state of Arizona. It's very small, and it is a very unusual moon. we could tell just by looking at its surface early on in the mission that it was unlike all the other icy satellites around Saturn. It has very few craters, and that means that the surface is young. You can only look at this to know it is